Hi students, let's continue our discussion, that is disc structure. As we all know, each disc platter is divided into number of tracks and each track is divided into number of sectors, right? And the sectors are the basic unit for read and write operation in the disc. And modern disk drives are addressed as a large one-dimensional arrays. These one-dimensional arrays of logical blocks are mapped onto sectors of the disk sequentially. So, these disk drives are nothing but large one-dimensional arrays of logical blocks where logical block is the smallest unit of transfer. Sector 0 is the first sector of the first track on the outermost cylinder. So, our array starts from the outermost cylinder and it continues to the innermost cylinder. That's why sector 0 is available on the first track, that is on the outermost cylinder. The mapping proceeds in order through the track, then through the rest of the tracks in that cylinder, and then through the rest of the cylinders from outermost to innermost cylinders. And these disk drives can be divided into two types. So, the disk structure or the architecture is being divided into two types. The first one is CLV, that is constant linear velocity, and the second type is CAV, that is constant angular velocity. In CLV, that is constant linear velocity, the density of bits per track is uniform. The density of bits per track is uniform in the sense the sector on each track will be having the same length. You can see the innermost sector length is same as that of the outermost sector length. Therefore, the density means the information that can be stored on each sector will be uniform. The density of bits per track is uniform. But since we are maintaining the density, the number of sectors per track will be changed. Innermost track is small in size. Correct? See, when you compare the size of the innermost track with the outermost track, the size is smaller. Therefore, it can hold small number of sectors. Even though the length of sectors are same, the innermost track can hold small number of sectors than the outermost track. Therefore, as we move from outer zones to inner zones, these are called zones. As we move from outermost zones to innermost zones, the number of sectors per track decreases. Obviously, right? Because the size of the track decreases as we move from outermost zone to innermost zones. That's why number of sectors will also decrease, but the length will remain same. So, this type of architecture is used in CD-ROM or DVD-ROMs. And the second type is constant angular velocity, that is CAV. In CAV, the density of bits per track is not uniform. You can see here, see the density of innermost track is more than the density of outermost track sector. The density is higher for the innermost sector. Therefore, there is same number of sectors in each track. Even though the density is not same, the number of sectors in each track will be same. The sectors are densely packed in inner tracks. The density of bits decreases from inner tracks to outer tracks to keep the data rate constant. So here the number of sectors available on each track will be same even though the density is not same. So this method is used in hard disks. These are used in hard disk drives. Okay. So these drives are addressed as large one-dimensional arrays of logical blocks. These logical blocks are nothing but sectors. And the first sector is available on the outermost cylinder. So there are two types of disk structure: constant linear velocity and constant angular velocity. In constant linear velocity, the density of bits per track is uniform. Therefore, the number of sectors available on each track will be different. So as we move from outer zones to inner zones, the number of sectors per track decreases. And in the second type, that is constant angular velocity, the density of bits per track is not uniform. The density of the sector available in innermost track is more than the density of the outermost sector. But the number of sectors available on each track will be same. Since we are not maintaining the density, we have to maintain some other aspect, that is here number of sectors available on each track. Therefore, as we move from innermost to outermost zones, the density decreases. Innermost zones have more densely packed sectors than the outermost zones. Okay. So in our next lecture, we are going to deal with disk attachment, different types of disk attachment and different types of storage attachments.